So for trigonometric equations, what is important, the most key thing, are the angles I hope you're getting me. So the most key thing here are the angles. So the most important the most important angles are 30, 45, and 60 degrees. So these angles, when you're doing equations, they are the key things that you need to know. Okay, so you need to know what sine 30 is, cos 30 is, tan 30, cos 45, cos 60. If you know what these what values you get when you use these angles, then you can go straight to before we can start looking at examples, we also pick the most important identity. Sine squared x plus cos squared x is equal to 1. Now we can go to examples. Our examples are coming from tutorial sheet. Tutorial sheet 5. We'll start with question. We'll start with question 7. Question 7 says, solve for x. Solve for x that lies in between 0 and 2 pi. One, 2 cos x is equal to 1. 2 cos x minus 1 is equal to 0. Now this is an equation. We want to solve for x. So the first thing we do is to take all other things that are not x the other side. So say we now have 2 cos x is equal to positive 1. And then we divide by 2, we divide by 2. And then we have cos x is equal to half. Well, this is the same thing as x is equal to cos inverse of half. If we are using calculators, the answer comes out here. If I'm not using calculators, I must know the values I get when I use 30, 45, and 60. So which one gives us half for cos? Cos x.
30.
Is it 30 or 60?
Half.
60.
60, sorry.
It's 60.
So we get 60 degrees. But look, the value of x that we must get is in the interval 0 to 2 pi. This means that our solution must be given in radians. So we convert this, we multiply by pi over 180 so that we get 3 here. So we get pi over 3. Okay, is that all? That is not all. We know that cos, as long as we're talking about 0 to 2 pi, we know that cos is positive here, cos is positive in the fourth quadrant. And the range 0 to 2 pi is positive. So we'll go all the way up to the fourth quadrant and look for an angle that gives us the same value as 30. So in the fourth quadrant, we'll have, this is the reference angle of that angle. Now we know that reference angles here are obtained by subtracting from 360. Now what we have is x. So we have pi over 3 is equal to 360 is 2 pi minus theta. We want to find theta, the angle that lies in the fourth quadrant. So we switch, we'll have theta is equal to 2 pi minus pi over 3. The common denominator is 3, and then we get 6 pi minus pi. So we have 5 pi over 3. So x is equal to pi over 3, and x is also equal to 5 pi over 3. So these two values of x are the solutions to this guy. Any questions?
Sorry, sir, kindly repeat.
Okay. So, what you're saying is, if the interval is from 0 to 360, 0 to 2 pi, and what we get here is a positive value, half is a positive value, we go to the quadrants where cos is positive, okay, and look for the angle that gives us half. In the first quadrant, it is 60. Then we know we can't go in the second quadrant because in the second quadrant, cos is negative. Cos is negative here, cos is negative here. So we can't talk about this. We can't talk about this. We have to talk about the first and fourth quadrant. Here we have found x is equal to 60. It means in the fourth quadrant, you get x is equal to 360 minus 60, which is 300. But express it as what? Express it in radians. Express your solutions in radians. So we don't have to forget what happens in the quadrants. We have to agree that we should never forget this thing. In the first quadrant, when it comes to reference angles, the issue of reference angles mostly depends on these very angles, these three. Now, in the first quadrant, if you are given any angle theta, if you're asked to find the angle theta, let me use x. If you're asked to find the angle x, That is a reference to the angles in the first quadrant. Then any angle they give you becomes the reference angle of itself. All the angles between 0 and 90 are reference angles of themselves. Then the angles between 90 and 180 have reference angles x obtained by subtracting those angles that lies in this quadrant from 180. So theta lies between 90 and 180. And then I'm looking for x that is a reference angle of theta. Then I get 180 minus theta. I'll have the reference angle. If it is in the third quadrant, then I'll subtract the angle I have minus 180. And if it's in the fourth quadrant, I'll subtract from 360 the angle that I have. Implying that if I now have x, okay, if I have x and I might solve for theta, if I have x and I might solve for theta, then you say theta here is equal to x plus 180. Theta here is equal to 360 minus x. And theta here is 180 minus x. And theta here is x. So the one in red is when you have an angle coming from the first quadrant, you want to find an angle related to that angle in the first quadrant. This is how you go around quadrants. In the second, you subtract the angle coming from the first quadrant to get the one in the second quadrant from 180. In the third quadrant, you add the angle you have plus 180 to get an angle that lies in this quadrant. Okay, so we'll see this as we do more examples so that you don't get confused. Okay, the next example. So the next example is B, where we have 2 sine x cos x plus cos x is equal to 0. This is an equation. So we don't divide variables. We factor out common variables. So we have cos here. So we'll factor out cos and we remain with 2 sine x plus 1 equal to 0. So we'll have cos x is equal to 0 or 2 sine x plus 1 is equal to 0. Then we'll say, well, cos x is equal to 0, yes, or sine x is equal to -1 over 2. We take positive 1 the other side and then divide by 2. Now let's start with cos x. For cos x is equal to 0. For the zeros, we go to, for zeros, we go to the other, to the angle 0, 90, 180, 270, and 360. These are the ones that can give us zeros here. So for cos, remember we had a graph of cos, and we saw that no, not for cos, but for positive cos. Yes. If the value on the if the value on the right is positive, then you get an angle from the first and the fourth quadrant. If it's negative, then you get from the second and third quadrant. So we saw that the graph of cos is of this kind, where this is 90 and this is 270 and this is 360 and this is 180 and the first one is 0. So talking of cos x is equal to 0, then we know x is equal to 90 and x is equal to 270. These are special angles. And then we convert them to radians. We multiply by pi over 180, giving us pi over 2. We multiply by pi over 180, giving us 3 pi over 2. You must be right. So let me check. What is 270 divided by 180 fraction? Oh, oh. This is not true. So let me do divide 0, 0, then 9 there, 3. So it's 3 pi over 2. Okay, yeah, like this. Then we got sin x is equal to negative half. Again, we check. So first we check which value gives us half for the positive sign. Sin x is equal to half. For which values? That is 30. So x is equal to 30 in the first quadrant. Sign is positive in the second quadrant as well. So in the second quadrant, we do 180 minus 30. We get 150. And then convert pi over 180. We get pi over 6. And convert, we get pi we get 5 pi over 6. Yes. So this means that our solutions are 4. X is equal to pi over 2, pi over 6, 3 pi over 2, and 5 pi over 6. Sign is negative half. You're right. Yeah. I got the positive one after wanting to use it. Okay. So this is not true. No, this is not true. So since sign is negative, we can first use the positive one to get 30. And then we start looking at where sign is negative in the third and fourth quadrant. So in the third quadrant, we have the angle 180 plus 30, which is 210. Since we said we add here. And then in the fourth quadrant, you have 360 minus 30, which is equal to 330. Since we said we subtract to get the angle that lies in that quadrant, if we are coming with the reference angle, then we change now to radian. So we have 3 there, that is 7 pi over 6. And here 3, that is 11 pi over 6. Yeah, so we have pi over 2. We also have 3 pi over 2. And then we have 7 pi over 6. And we have 11 pi over 6. So these are the 4 angles that we get. 2 for cos is equal to 0. 2 for sine is equal to negative half. Okay, so don't worry about the graphs. I've put them on hot so that we can, because once we got the graphs, then we'll be finishing the topic. That's why I've come back, because I know I skipped the equations. I just talked about the angles. Okay, so we go to the next one. The next one, C is 2 sin x tan x minus tan x is equal to 1 minus 2 sin x. So first, let's put everything together. No, 30 is not the solution. 30 was just helping us to. So 30 is a reference angle that helped us to get other angles from the third and the fourth pattern. Because you need 30 for you to get a 210 and for you to get 330. Okay, so we have C. So we take these the other side and see if we can use them. So we have 2 sin x tan x minus tan x plus 2 sin x minus 1 is 0. And then we factor out, I think let's factor out tan from here and see what we get. We factor out tan, we remain with 2 sin x minus 1 plus 2 sin x minus 1 is equal to 0. If we factor out what is common, this we have 2 sin x minus 1, and then we remain with tan x here, and we remain with 1 from here is equal to 0. Then we say this means that 2 sin x minus 1 is 0, or tan x plus 1 is 0. This implies that sin x is 1 over 2, or tan x is equal to negative 1. So for sin x is equal to half, I think we had already found the solution in the previous question, where sin is 30, which is pi over 6. And the other one, in the second quadrant, we had found 150, which is, was it 5 pi over 6? I think so. Yes, there's 2. Because sine is half and it's positive. Now let's go to tan. So first, the trick here is you first ignore the negative. Tan x is 1. You go for this first for you to get the reference angle. So you know that happens when x is 45. How do we get an x plus 1? So look at what we have. We have this whole thing here, and tan is common here. So we factor out tan. We remain with 2 sin x minus 1 plus 2 sin x minus 1. Now we see that we have this guy here and inside. So we factor this out. We'll have 2 sin x minus 1 in brackets. Now we divide this in here. I will remain with tan x. So we put it here plus this whole thing in here. It will give us 1, like the quadratic. And then we split this equal to 0. Say, okay, so for when x is positive 1, I mean, when tan x is positive 1, we know the angle there is 45. But our tan is negative. So it means it's in the second quadrant. So in the second quadrant, 45 is actually 180 minus 45. So we get 135. 135 degrees. We convert this to pi over 180. What we get? Which numbers to use? If I try 5, you see the big anybody to reduce a bit and to guide us. So if we try 5 into 13, 2, remainder 3. 5 into 35 equals 7 times over 5 into 18 equals 3 times, remainder 3. 5 into 36 pi. So here you can use 9 there, 3 pi, 9 here, 4. Okay, so we get 3 pi over 4. 1. This is in the second quadrant where tan is negative. We also have another angle in the fourth quadrant. X is equal to 360 minus 45. This is 3 15. Yeah, 315. Then we convert it pi over 180. Another drama here. So let's see. We use 5 into 30, that is 6. Remainder 1. 5 into 15, that is 3. Yeah, that is 3. Pi over 5 into 180, we got 36. Then now which one goes? Is it the same 3? I think the same 3. In 63, it goes 21 times. And in 36, it goes 12 times. I think 3 is still going. It goes 7 and it goes 4 down. 37 pi over. Meaning that the solutions from here, we have x is pi over 6. X is 5 pi over 6. And x is 3 pi over 4 and 7 pi over 4. That is the thing. So do we have any question? Okay, so we'll be cutting and quickly we rejoin so that we can finish up on the equations.